Complex numbers, polar coordinates, and parametric equations. So we're giving a square root of 3 minus an I, which is called the imaginary. In trigonometry form, we're going to use the degree measure for the argument. We're going to solve for the missing pieces here. So I need to figure out what is my R value here and what are our angles. And we're going to do it in degrees for this one. So we're going to go back and go do a little refresher. We have Z is equal to A plus BI. So the real plus or minus the imaginary. It is a complex number. We know that Z is equal to R times that cosine of an angle plus I sine of an angle. Okay, where R is equal to the square root of A squared plus B squared. And my order pair is called A comma B instead of X comma Y. Okay, so we are giving the square root of 3. We're going to call that A minus my IB, right? Okay, so we're good so far. If I was to state what my A is square root 3 here, and my B is -1, because remember, I is attached to it. Okay, so let's find R. Let's change this to orange. Find R. So my A squared plus my B squared, which is 3 plus 1, which is 4, which is 2. So R is 2. Let's do. So now I get right here, my R is 2 cosine of some angle plus I sine some angle. So if you wanted to we're going to rewrite it again, make it a little bit neater. All right, so now let's solve for the next part. What we know is in our order pair, we got A comma B. We know it's cosine comma sine. We know that. So then that means A equals R cosine and B, oh yeah, don't forget the angle. And then B equals R sine. Okay, so we know that much. So let's take the A equals R cosine theta. And let's plug in what we know. What we know is A is square root 3 and R is 2. We get cosine theta. I want to divide both sides by that 2 to get cosine theta by itself. So now I get cosine theta is equal to square root 3 halves. Let's take the inverse of cosine to get theta by itself. So we can plug this in our calculator, the inverse of cosine. Make sure you're in degrees mode. And we should get 30 degrees. Just double checking. Yes, 30 degrees. Yay. All right. So next, I'm going to say, okay, I'm going to take, because when we talk about the unit circle, we talk about a total of 336 degrees. Oh, sorry, I said that wrong. 360. I said 36. My apologies. So I'm going to take 360 minus that 30 degrees, and that gives me 330 degrees. Right? So now let's write our answer out here. So we have 2 cosine 330 degrees plus I sine 330 degrees. And that is our answer. Okay, let's do our next example. So our next example says, convert the polar coordinates of the point to the rectangular coordinates. Square root 3, 150 degrees. All right, so let's do that. So when we're talking about polar, we're still talking about order pair. Instead of x comma y, now we got r comma theta. Okay, where x is equal to r cosine theta and y is equal to r sine theta. We still have those. We know what r is here. R is the square root of 3 and theta is 150 degrees. So let's solve for x equals r cosine 150 degrees. When I do that, I'm going to end up getting square root of 3 cosine of 150 degrees is going to be negative square root of 3 halves. So what do I have now? I'm going to put this over 1, right? Multiply straight across, negative times positive. 3 times 3 over 2, because the roots are the same, I can do that. It gives me this. Square root of 9 is 3, so I get a negative 3 halves. So I know what x is. Let's find y. So y is 100. Oh, excuse me. Still go back to the formulas. My apologies, guys. Y is r square root of 3 sine of 150 degrees. So I got square root of 3 times sine of 150 degrees is going to be a half. We can say square root of 3 over 1 times that half, multiply straight across, I get square root of 3 halves. So I know what y is, so I know now I get negative 3 halves, comma, square root of 3 halves. And that is my answer. Let's see, do we have any more examples? I believe that finished this one.